So now let's consider some of the geometry of the truncated octahedron. Here's the shape itself, looked at from the center outwards. And here's a rather tatty octahedron from which it's been derived. So how is this truncated? Well, we can imagine a slice being taken straight down there, straight down there, straight down there, knocking a square-based pyramid off every vertex of the octahedron. So that's going to be 6 square-based pyramids, as you can see, 3 here and 3 there. This face, this petal, it's not a face, it's more like a petal, is going to be divided precisely in 3. That edge will be divided into 1, 2, 3. And so I've made a diagram of that right-angled isosceles petal here. And for our purposes, it's going to be best if we call that length not 1, but 3 root 5, and it will become clear why that's the case later on, 3 root 5. So there's my isosceles right-angled triangle. Now, 3 root 5 squared and 3 root 5 squared is going to give you 45, isn't it? That's 45, and that's 45. Add them together and you're going to get 90. And if you take the square root of 90, that's going to give you a length here of 3 root 10. And that's going to be handy because we're going to be dividing it into 3 anyway, this hypotenuse. But just looking at this right-angled triangle here, it's another isosceles right-angled triangle. And by symmetry, you can see that this part here is 3 over 2 root 10. So if that's equal to that, this is also 3 over 2 root 10. And that's moved us forward helpfully. But we don't need that anymore, so we'll get it out of the way. Now we're going to divide this hypotenuse in 3 using a ruler and set square. So I just draw a line down there and I divide it with my compass. So that's 1 unit, that's 2 units, and that's 3 units. And if I put my set square here, so that the line from that final point to the end point is like that, then I can put the ruler underneath and draw a parallel line at this point, which is going to come down there and cut there, and then I can do the same, I hope. I'm going to slide it up a bit. There we go. And then there's another one there. So now I've divided this line into 3. Once again, we don't really want this anymore. It's only going to confuse us. So that's nice and clear. And at this point, I'm going to join the vertex at the middle of the shape. The vertex of the triangle, which is the center of both the octahedron and the truncated octahedron, and we'll draw in the isosceles triangle. There it is, and there it is. Now if this section is root 10, then this little bit here is root 10 over 2. From here to there is root 10 over 2, and we already know that this length from there to there is 3 over 2 root 10, and there's our right angle. So we can now find the length from here to there, which corresponds to that length in our truncated octahedron. There's our isosceles triangle again. So let's use Pythagoras. That squared is going to be 10 over 4. This squared is going to be 10 times 9 over 4. and that's actually going to work out as 100 over 4, or 25, giving us this length to be 5. Now that might suggest something to us, but we haven't quite made our full point yet. We're going to need to drop one more perpendicular from, say, that point down to there. Now we ought to notice that this is a right-angled triangle, and that as this angle is common both to that triangle and this triangle, those two triangles are similar. And if I call that length h, I can say that that length h over the corresponding hypotenuse is the same as that length 3 over 2 root 10 over the hypotenuse which corresponds, namely 5. So if I write this, h divided by, now I've made a mistake here because the hypotenuse of this triangle is the whole length there, which is actually root 10, not root 10 over 2. So h divided by root 10, that's that length going down to the right angle divided by the hypotenuse, is going to equal this length, which is 3 over 2 root 10 divided by the hypotenuse, which is 5. So writing that out, 8 over root 10, h over root 10, is going to equal 3 root 10 over 2 times 5 over 10. That's 3 over 2 times a fifth, which is 3 over 10 times root 10. And when I cross multiply by root 10, I'm going to get 3 times 10 over 10, which is 3. So now we know that h is 3. And this is a right-angled triangle where, now let's get it straight, it's this length which is 5, it's that length which is 3, so this length from there to there must be 4. So it turns out that we have, if we're mathematicians, a very old friend hidden in the center of a truncated octahedron. We've got the sharpest angle of the 3 to 4 to 5 triangle. And there it is. Well, thank you for watching, and I trust you were able to follow that geometry without too much difficulty, and appreciate what that angle actually is.